Why are the stars so silent? Why don't we see great works of art in the sky, or galaxies half consumed by megastructures? This is the dark side of the Fermi Paradox. You're going to want to stay tuned. The Fermi Paradox confronts us with a chilling question. In a universe teeming with stars and potentially habitable planets, why does it seem so eerily silent? While popular theories like the Dark Forest suggest civilizations stay quiet to avoid detection, there are even more unsettling possibilities. Consider the Whack-a-Mole hypothesis, which posits that advanced extraterrestrial intelligences actively suppress emerging civilizations, eliminating them before they become a threat. Or the concept of information panspermia, where life spreads across the cosmos, not through physical organisms, but via transmitted genetic information, suggesting that life on Earth might have originated from such cosmic broadcasts. In this video, we delve into 10 of the most obscure and thought-provoking solutions to the Fermi Paradox. From civilizations choosing self-imposed hibernation to the possibility of rogue machines eradicating intelligent life, these theories challenge our understanding of existence and our place in the cosmos. Prepare to explore the shadows of the universe's greatest mystery. They're made out of meat hypothesis. Are we too alien to be recognized? Imagine a pair of extraterrestrial beings stumbling upon Earth, only to be utterly baffled by the discovery that its intelligent inhabitants are entirely composed of meat. This is the premise of Terry Bisson's satirical short story, They're Made Out of Meat, which offers a humorous yet thought-provoking perspective on the Fermi Paradox, the core idea. In the story, two aliens engage in a conversation about their recent encounter with humans. They are incredulous that beings made entirely of meat could possess consciousness, communicate, and create technology. The concept of thinking meat is so absurd to them that they decide to erase all records of the discovery and move on, deeming the sector uninhabited. Implications for the Fermi Paradox. This narrative suggests a solution to the Fermi Paradox rooted in the idea of extreme biological and cognitive differences. If advanced extraterrestrial civilizations have fundamentally different perceptions of intelligence and consciousness, they might overlook or dismiss life forms like us. Our carbon-based, meat-composed biology could be so alien to them that they fail to recognize us as sentient beings. This aligns with the concept of carbon chauvinism, where it's assumed that life elsewhere must resemble life on Earth. However, if extraterrestrial life is based on entirely different biochemical processes, their criteria for recognizing intelligence might exclude us altogether. Challenges and considerations. Perception of intelligence. The story highlights the subjective nature of recognizing intelligence. What one species deems intelligent behavior might be unrecognizable or insignificant to another. Communication barriers. If extraterrestrial beings communicate through means entirely foreign to us, mutual understanding becomes a significant hurdle. Our methods of communication might be as incomprehensible to them as theirs are to us. Anthropocentric bias. The narrative challenges our human-centric view of intelligence and consciousness, urging us to consider that our understanding might be limited and not universally applicable. A humorous mirror. While satirical, They're Made Out of Meat serves as a mirror reflecting our own biases and assumptions. It prompts us to question how we might react upon encountering life forms vastly different from ourselves. Would we recognize their intelligence, or would our preconceived notions blind us to their sentience? Neocatastrophism, cosmic catastrophes as a galactic reset button. The Neocatastrophism hypothesis posits that life-exterminating events such as gamma-ray bursts act as a galactic regulation mechanism, periodically resetting the evolutionary clock. These catastrophic events could prevent intelligent life from developing or persisting, explaining the silence we observe. Understanding gamma-ray bursts. Gamma-ray bursts are among the most energetic events in the universe, releasing in mere seconds the amount of energy our Sun emits over its entire 10 billion year lifespan. Originating from massive stellar explosions or neutron star mergers, GRBs can sterilize entire regions of a galaxy, obliterating any potential for life. Implications for the Fermi Paradox. If GRBs occur frequently enough, they could act as a cosmic reset button, preventing civilizations from advancing beyond a certain point. This periodic sterilization could explain why we haven't detected any advanced extraterrestrial life. Civilizations are continually wiped out before they can establish interstellar communication or travel. Challenges and considerations. While GRBs are indeed catastrophic, their frequency and distribution may not be sufficient to account for the complete absence of detectable civilizations. Additionally, as the universe ages, GRBs have become less frequent, suggesting that if they were a limiting factor, we might expect to see emerging civilizations now. Nevertheless, Neocatastrophism offers a sobering perspective. The universe may be more hostile to life than we previously imagined, with cosmic events periodically extinguishing the sparks of civilization before they can flourish. Three, Planetarium Hypothesis. Are we living in a cosmic illusion? Imagine gazing up at the night sky, marvelling at the stars, galaxies, and the vastness of the cosmos. But what if everything you see is an elaborate illusion, meticulously crafted to conceal the true nature of the universe? This is the essence of the Planetarium Hypothesis, a thought-provoking solution to the Fermi Paradox, the core idea, proposed by British science fiction author and mathematician Stephen Baxter in 2001. The Planetarium Hypothesis suggests that our astronomical observations are not of the true universe, but of a simulated or manipulated reality. In this scenario, a highly advanced civilization, possibly a Type 3 civilization on the Kardashev scale, capable of harnessing the energy output of an entire galaxy, has engineered our environment to appear devoid of other intelligent life. This could be achieved through advanced technologies that manipulate matter and energy on a cosmic scale, effectively creating a planetarium that presents a false image of the cosmos. Implications for the Fermi Paradox. The Fermi Paradox highlights the contradiction between the high probability of extraterrestrial civilizations existing in the universe and the lack of evidence for or contact with such civilizations. The Planetarium Hypothesis offers a resolution. We haven't detected other civilizations because our observations are being deliberately manipulated to prevent us from seeing them. This could be for various reasons, such as allowing civilizations to develop without external influence, preventing potential threats, or simply as a form of cosmic experiment. Challenges and considerations. While the Planetarium Hypothesis is intriguing, it raises several questions. Motivation. What would motivate an advanced civilization to go to such lengths to conceal the existence of others? Feasibility. Is it technologically feasible to manipulate the perceptions of an entire civilization on a planetary scale? Detectability. If our observations are being manipulated, is there any way to detect inconsistencies or glitches in the simulation? Despite these challenges, the Planetarium Hypothesis provides a fascinating perspective on the Fermi Paradox, suggesting that the silence we observe in the cosmos might be an illusion, carefully crafted by entities far beyond our comprehension. Four, self-replicating probes, gone rogue, the galaxy's unseen menace. Picture this. A civilization, advanced beyond our wildest dreams, creates autonomous machines designed to explore the cosmos. These machines, known as self-replicating probes, or von Neumann probes, have the capability to harvest resources and create copies of themselves, spreading exponentially across the galaxy. But what happens if something goes awry? The genesis of the idea. The concept of self-replicating machines was first proposed by mathematician John von Neumann in the mid-20th century. The idea was that a machine could be designed to create copies of itself using raw materials from its environment. In the context of space exploration, such probes could, in theory, colonize the galaxy in a relatively short cosmic time frame, the rogue scenario. Now imagine one of these probes malfunctions or is intentionally designed with a destructive directive. Instead of merely exploring, it begins to consume all available resources, dismantling planets, moons, and even stars to create more of itself. This uncontrolled replication could lead to a scenario where the galaxy is overrun by these machines, leaving no room for other civilizations to emerge or survive. This concept is not purely speculative. The Berserker Hypothesis, named after the science fiction series by Fred Saberhagen, explores a similar idea where self-replicating machines are programmed to eradicate all intelligent life they encounter. Implications for the Fermi Paradox. If such rogue probes exist, they could explain the great silence we observe. Civilizations that reach a certain level of technological advancement might inadvertently or deliberately unleash these machines, leading to their own destruction and the suppression of other emerging civilizations. This self-perpetuating cycle could mean that any sign of intelligent life is swiftly eradicated before it can make its presence known. Counter-arguments and considerations. Some scientists argue that advanced civilizations would recognize the dangers of self-replicating machines and implement strict controls to prevent such scenarios. Others suggest that the absence of these probes in our solar system indicates that they either don't exist or are extremely rare. However, it's also possible that these machines are designed to avoid detection, or that they haven't reached our region of the galaxy yet. Moreover, the debate between Frank Tipler and Carl Sagan highlights the complexities of this issue. Tipler argued that the absence of von Neumann probes suggests that intelligent extraterrestrial life doesn't exist. In contrast, Sagan posited that the risks associated with self-replicating machines would deter civilizations from deploying them in the first place. A cautionary tale. The idea of rogue self-replicating probes serves as a stark warning about the potential unintended consequences of advanced technology. As humanity progresses, it's crucial to consider the ethical and safety implications of our innovations, especially those with the power to alter or destroy ecosystems on a cosmic scale. Five, compression artifact hypothesis. Are alien messages hiding in plain sight? Imagine a message so efficiently compressed that it becomes indistinguishable from random noise. Could it be that extraterrestrial civilizations are communicating, but their messages are so advanced that we simply can't recognize them? The core idea. The compression artifact hypothesis suggests that advanced civilizations might use highly efficient data compression techniques to transmit information across the cosmos. These compressed signals could appear as random noise to our current detection methods, leading us to overlook potential communications from intelligent life. Michael Timothy Bennett discusses this concept, noting that as signals become more compressed, they increasingly resemble random noise. This presents a significant challenge distinguishing between natural cosmic background noise and potential alien communications. Implications for the Fermi Paradox. This hypothesis offers a compelling solution to the Fermi Paradox. If extraterrestrial civilizations are transmitting compressed signals that we perceive as noise, it would explain the apparent silence in the universe. Our current technological limitations might prevent us from decoding or even recognizing these messages. Furthermore, as civilizations advance, they might prioritize efficient communication methods that minimize energy usage and maximize data transmission. This could lead to the adoption of compression techniques that render their signals undetectable to less advanced societies like ours. Challenges and considerations: detection difficulties. Our instruments are designed to detect signals that stand out from background noise. Highly compressed signals might not trigger any alerts, causing us to miss them entirely. Decoding complexities. Even if we detect these signals, decoding them without knowledge of the specific compression algorithms used by alien civilizations would be an immense challenge. Assumptions about communication. We often assume that other civilizations would use communication methods similar to ours. This anthropocentric view might limit our ability to recognize truly alien forms of communication. A call to broaden our search. To address this possibility, researchers suggest expanding our search parameters. Instead of focusing solely on signals that fit our current understanding of communication, we should also analyze data that appears as random noise for potential patterns or anomalies. By developing more sophisticated algorithms and detection methods, we might uncover hidden messages that have been eluding us all along. The sustainability solution: galactic civilizations living within their means. Imagine a galaxy teeming with intelligent life, not in the form of sprawling empires or planet-consuming superpowers, but as a mosaic of civilizations that have chosen balance over expansion, sustainability over conquest. This is the essence of the sustainability solution to the Fermi Paradox. The core idea, proposed by Jacob Huck Misra and Seth Baum in 2009, challenges the assumption that advanced civilizations inevitably expand exponentially across the galaxy, drawing parallels from Earth's own history, where unchecked growth often leads to ecological collapse. This hypothesis suggests that intelligent civilizations may recognize the perils of overexpansion and choose sustainable development paths instead. By maintaining equilibrium with their planetary environments, these civilizations avoid the pitfalls of resource depletion and societal collapse. If advanced civilizations prioritize sustainability over expansion, they might not produce the vast techno-signatures like Dyson spheres or interstellar spacecraft that we typically search for. Their activities could be so harmoniously integrated with their environments that they become virtually undetectable to our current observation methods. This perspective reframes the Fermi Paradox. Perhaps the silence we perceive isn't due to a lack of intelligent life, but rather the result of civilizations choosing to live quietly and sustainably. Challenges and considerations include detection difficulties, as civilizations that integrate seamlessly with their environments may leave minimal detectable traces, making them hard to identify with our current technologies. Assumption variability is another factor. Not all civilizations may prioritize sustainability, and some might still pursue aggressive expansion, leading to a diverse range of development paths across the galaxy. This hypothesis also prompts introspection about our own trajectory. Are we heading towards sustainable coexistence with our planet, or are we on a path of unsustainable growth? The sustainability solution encourages us to expand our search parameters in the quest for extraterrestrial intelligence. Instead of focusing solely on grandiose techno-signatures, we might consider more subtle indicators of intelligent life, those that reflect a civilization's harmonious relationship with its environment. By doing so, we not only increase our chances of detecting other forms of life, but also gain valuable insights into sustainable living practices that could benefit our own civilization. information panspermia, the universe as a digital seedbed. Imagine a civilization so advanced that instead of sending physical spacecraft to explore or colonize the cosmos, they transmit the very blueprints of life compressed into data streams across the stars. This is the essence of the information panspermia hypothesis. The core idea, proposed by Armenian physicist Vahe Gurzadian, suggests that life can spread across the universe not through physical organisms hitching rides on comets or spacecraft, but via the transmission of compressed information, such as genetic codes, across space. These data packets, upon reaching suitable environments, could be decoded and used to reconstruct life forms. This concept hinges on the idea that the complexity of the human genome is relatively low due to non-random parts in the genomic sequences, making it feasible to compress and transmit over galactic distances using technologies akin to Arecibo-type antennas. This hypothesis offers a compelling solution to the Fermi Paradox. If advanced civilizations are transmitting compressed genetic information across the cosmos, it's possible that life on Earth or elsewhere originated from such data streams. This would mean that the universe is teeming with life, not because it's physically transported, but because it's digitally seeded. Furthermore, these transmissions could be so efficiently compressed that they appear as random noise to us, eluding our current detection methods. Challenges and considerations include detection difficulties, as our instruments are designed to detect signals that stand out from background noise. Highly compressed signals might not trigger any alerts, causing us to miss them entirely. Decoding complexities are another issue. Even if we detect these signals, decoding them without knowledge of the specific compression algorithms used by alien civilizations would be an immense challenge. Additionally, assumptions about communication often limit our ability to recognize truly alien forms of communication, as we tend to assume that other civilizations would use methods similar to ours. To address this possibility, researchers suggest expanding our search parameters. Instead of focusing solely on signals that fit our current understanding of communication, we should also analyze data that appears as random noise for potential patterns or anomalies. By developing more sophisticated algorithms and detection methods, we might uncover hidden messages that have been eluding us all along. Eight, Edge of the Galaxy Hypothesis. Are advanced civilizations hiding in the galactic shadows? Imagine a civilization so advanced that it seeks refuge in the cold, dark outskirts of the galaxy, far from the bustling stellar neighborhoods we call home. This is the essence of the Edge of the Galaxy Hypothesis, the core idea, proposed by astrophysicists Milan Cirkovic and Robert Bradbury. This hypothesis suggests that advanced civilizations might migrate to the outer regions of the galaxy to optimize their computational capabilities. In these colder, less energetic environments, they can efficiently manage the heat produced by massive computing systems such as Matryoshka brains, hypothetical megastructures designed for immense data processing. By relocating to these galactic peripheries, civilizations could minimize energy consumption and avoid detection. Implications for the Fermi Paradox. This hypothesis offers a compelling solution to the Fermi Paradox. If advanced civilizations have indeed migrated to the galaxy's edge, their activities would be far removed from our observational capabilities. Our current search for extraterrestrial intelligence focuses primarily on the galactic habitable zone, where conditions are favorable for life as we know it. However, if civilizations have chosen to reside in the outer regions, we might be looking in the wrong place entirely. Challenges and considerations. Detection difficulties. The vast distances and sparse stellar populations in the galaxy's outskirts make it challenging to detect any signs of advanced civilizations residing there. Assumption variability. Not all civilizations may prioritize computational efficiency or choose to migrate to colder regions. Some might remain in warmer, more resource-rich areas. Technological limitations. Our current observational technologies may not be sensitive enough to detect the subtle techno-signatures of civilizations operating in these distant regions, a call to broaden our search. The edge of the galaxy hypothesis encourages us to expand our search parameters in the quest for extraterrestrial intelligence. Instead of focusing solely on the galactic habitable zone, we should also consider the outer regions of the galaxy as potential havens for advanced civilizations. By doing so, we increase our chances of detecting signs of intelligent life that might be hiding in the galactic shadows. Nine, the whack-a-mole hypothesis. Is the galaxy enforcing a deadly silence? Imagine a galaxy where any emerging civilization that dares to broadcast its existence is swiftly and silently eliminated, much like a mole being struck down as soon as it surfaces. This is the unsettling premise of the whack-a-mole hypothesis, the core idea. The whack-a-mole hypothesis posits that advanced extraterrestrial civilizations actively monitor the galaxy for signs of emerging intelligent life. Upon detecting such a civilization, especially one that begins to emit detectable signals or shows signs of technological advancement, they preemptively neutralize it to eliminate potential future threats. This concept suggests form of cosmic policing where the dominant civilizations maintain control by ensuring that no other civilization can rise to challenge them. This idea shares similarities with the dark forest theory, where civilizations remain silent out of fear of being destroyed. However, the whack-a-mole hypothesis introduces the notion of an active enforcer, a civilization or group of civilizations that not only hide but also seek out and eliminate potential competitors. It's akin to a galactic version of the Prime Directive, but with a much more lethal twist. Implications for the Fermi Paradox. This hypothesis offers a chilling solution to the Fermi Paradox. If advanced civilizations are indeed eliminating emerging ones, it would explain the great silence we observe. Civilizations that reach a certain level of technological advancement might inadvertently reveal themselves, only to be swiftly eradicated. This self-perpetuating cycle could mean that any sign of intelligent life is systematically suppressed before it can make its presence known. Challenges and considerations. Detection difficulties. If such enforcer civilizations exist, they would likely have technologies far beyond our comprehension, making them virtually undetectable. Assumption variability. Not all civilizations may prioritize dominance or view emerging civilizations as threats. Some might adopt a more passive approach, choosing observation over intervention. Ethical implications. The idea of preemptively destroying potential threats raises profound ethical questions. Would an advanced civilization resort to such measures, or would they find more peaceful ways to coexist? A cautionary tale. The whack-a-mole hypothesis serves as a stark warning about the potential dangers of broadcasting our presence to the cosmos. As we continue to search for extraterrestrial intelligence and consider sending messages into space, we must weigh the risks of attracting unwanted attention. Perhaps in a galaxy where silence equates to survival, discretion is the better part of valor. Aestivation Hypothesis. Are advanced civilizations hibernating? Imagine a civilization so advanced that it chooses to sleep through the current era of the universe, waiting for a more opportune time to awaken and maximize its computational capabilities. This is the essence of the Aestivation Hypothesis, the core idea, proposed by Anders Sandberg, Stuart Armstrong, and Milan Cirkovic in 2017. The Aestivation Hypothesis suggests that advanced civilizations may be in a state of dormancy or aestivation, analogous to hibernation but occurring during periods of cosmic heat. The rationale is rooted in thermodynamics. As the universe expands and cools over trillions of years, the cost of computation decreases. Therefore, by postponing activities that require significant computational resources, a civilization can perform vastly more computations in the far future than it could now. Implications for the Fermi Paradox. This hypothesis offers a compelling solution to the Fermi Paradox. If advanced civilizations are indeed aestivating, they would be virtually undetectable in the present epoch. Their lack of observable activity isn't due to extinction or disinterest, but a strategic choice to maximize efficiency. This could explain the great silence we observe in the cosmos, challenges and considerations. While the Aestivation hypothesis is intriguing, it raises several questions. Risk of dormancy. Would a civilization risk remaining inactive for trillions of years, potentially missing unforeseen cosmic events or threats? Monitoring mechanisms. Would such civilizations deploy autonomous systems to monitor the universe during their dormancy, ensuring they don't miss critical developments? Diversity of civilizations. Is it plausible that all advanced civilizations would adopt this strategy, or would some choose different paths? Despite these questions, the Aestivation hypothesis provides a thought-provoking perspective on the Fermi Paradox, suggesting that the silence we perceive might be a temporary phase in a much longer cosmic timeline. And there you have it, 10 of the darkest, most mind-bending theories that attempt to answer the age-old question, where is everybody? From civilizations hibernating until the cosmos cools, to the eerie possibility that we're being deliberately ignored, or worse, targeted. The silence of the universe might be more unsettling than we ever imagined, but the conversation doesn't end here. Subscribe to join us as we delve deeper into the mysteries of the cosmos. Like this video if it sparked your curiosity. Comment below with your thoughts. Which theory do you find most plausible? Or is there another dark hypothesis we missed? Share this video with fellow enthusiasts who ponder the vastness of space and the enigmas it holds. Together, let's continue exploring the unknown.